Have you wondered how it's possible to scratch a CD or a DVD and still have a playback whatever it's stored? The scratch really does affect one's materials on the disk, so it reads off different data from what was stored. But unless it's really scratched up, the bits that are read off are decoded into precisely the same file that was encoded into, a bit-for-bit copy, despite all of those errors. There's a whole pile of mathematical cleverness that allows us to store data and, just as importantly, to transmit data in a way that's resilient to errors. Well, okay, it doesn't take that much cleverness to come up with a way to do this. Any file, whether it's a video or a sound or a text or some code or an image, whatever, is ultimately some sequence of ones and zeros. And the simple strategy to correct any bit that gets flipped would be to store 3 copies of each bit. Then the machine reading this file could compare these 3 copies and always take the best out of whatever the discrepancy is. But what that means is using 2/3 of your space for redundancy. And even then, for all of that space given up, there's no strong guarantee what happens if more than one bit gets flipped. The much more interesting question is how to make it so that errors can be corrected while giving as little as possible. For example, using this method you'll learn in this lecture, you can